Hello, I'm Kingsley, and today I'll be going over applications of reflection properties. One application of a reflection property is orbit, and I chose question 49 to help explain this, and it says, the point in a lunar orbit nearest the surface of the moon is called perilune, and the point farthest from the surface is called apolune. The Apollo 11 spacecraft was placed in an elliptical lunar orbit with perilune altitude of 110 kilometers and an apolune altitude of 314 kilometers above the moon. Find an equation of this ellipse if the radius of the moon is 1,728 kilometers and the center of the moon is at one focus. So the first thing you want to do here is draw out the diagram of what the problem gives you. So it gives us the moon and an elliptical orbit, and the moon has a radius of 1,728 meters, a perilune of 110 meters, and an apolune of 314 meters. And we want to assign points to a few things. First, we want to assign a point to the center of the moon since that is our one focus. So I put that as C0. And the two ends of the orbit will be A0 and negative A0. And just to reflect everything over the y-axis, I put a point negative C0 over here. And then the next thing we want to do is choose which ellipse equation we want to do. And we have this one where x squared is over a squared, and that's if our focus point is on the x-axis. Or we can have y squared over a squared, which is if our focus would be on the y-axis. And since our focus is on the x-axis this time, we choose this equation. And then the last thing we need is the equation to find out b, since we only have a and c so far. And the textbook gives us b squared equals a squared minus c squared. So now we have everything to try and find our equation. And what we want to do first is find the value of a, which we can do by adding both the radius of the moon with the, I forgot which altitude it is, the apolune altitude of 314, and then adding the radius with the perilune altitude of 110, and then dividing both of them by 2, and then our a value is 1,940. And we want to do something similar for c, except subtract them this time, and then we get 102. So now we can find b, where b squared is now equal to a squared minus c and c squared, and since we found a and c, it's just 1,940 squared minus 102 squared, and then we get a value of b squared is equal to 3,753,196. And then we plug that all into this equation here, and to get a squared, we just square 1,940, and we get 3,763,600, and then we already have our b squared value, so we just put that there, and then we plug everything in, and this would be our final equation for this elliptical.